Now that we've defined vectors geometrically, let's talk about vectors in the coordinate system. And I'm going to start by defining two very particular vectors. I'm going to start with the two vectors that start at the origin and extend along the positive x and y axis and have length 1. So let's start with that horizontal one. This is a horizontal vector of magnitude 1, and we denote it by I. It starts at the origin and ends at the point 1, 0. The other one is a vertical vector of magnitude 1, and we denote it by J. So we have a horizontal vector and a vertical vector that we want to define. And this helps us define all of the vectors in our coordinate system. Let's suppose I have my coordinate system and I have some vector that starts at the origin and ends at the point A, B. In this case, we can write the vector as v is equal to a times I plus b times j. We write it as how far it moves in the x direction plus how far it moves in the y direction. The number a is known as the horizontal component since it tells us how much we move horizontally. The number b is known as the vertical component since it tells us how much we move vertically. And in this case, it's actually much easier for us to determine the magnitude of this vector. We have that the magnitude of v is equal to the square root of a squared plus b squared. However, it's important to note that this only works if the vector is written in this form, ai plus bj. Let's consider this vector negative 3i plus 4j. We move horizontally by negative 3 and vertically by 4 to get this point here. This point, negative 3, 4. So this vector starts at the origin and extends to the point negative 3, 4. We can also talk about the length of this vector. Since it does start at the origin, it is written in this ij form. We have that it's negative 3 squared plus 4 squared. Negative 3 times negative 3 is 9. 4 times 4 is 16. 9 plus 16 is 25, and the square root of 25 is 5. So the magnitude of this vector is 5. What we've been doing so far does rely on the fact that the vector starts at the origin. But what if it doesn't? What if it starts at a different point? It has a different initial point. Vectors are defined by their direction and their magnitude and nothing else. Where they physically are in the plane is not important. So I can think about taking up a vector, picking it up, and moving it somewhere else. And it doesn't change the actual vector. So what I want to do is pick up this vector and move it so that this initial point gets back to the origin. And I can do that using this formula here. The new vector in ij form is x2 minus x1 times I plus y2 minus y1 times j. And this is the result of picking this vector up and shifting it so that that initial point is at the origin. Let's consider a vector whose initial point is 3, -1 and terminal point is 2, -5. So my formula says x2 minus x1. We need to do terminal point minus initial. So for the x coordinates, we have -2 minus 3 times I. And then for our y, we have 5 minus -1 times j. This gives me the vector -5i plus 6j.